Hi students, our study is about analytical geometry. We're going to start by the three-dimensional graph. You have the x-axis, the y-axis, the z. Here the dot is the x negative, here the dot y negative, and elevation here z negative. I want to locate the point whose components are 1, 2, minus 2. So I go to the x-axis 1, on the y-axis 2. I complete the parallelogram, then I go down a parallel to the z-axis but negative down minus 2. So here the point A. Okay, if I want to locate the point B whose components are 2, minus 1, 2, so I go x-axis 2 units, y minus 1, to the left we go, and then complete parallelogram, and I go elevation 2. So this is locating points in three-dimensional figure. Now suppose I have a system, center is A, the x-axis is unit 1 AD, y-axis AB 1, and AE is the elevation, the z-axis. So the component of A 0, 0, 0, B it's on the y-axis, so 0, 1, 0. C you have x is 1, y is 1, and no elevation. D here you have on the x-axis 1, 0, 0. E you have 0, 0, 1, etc. Let us see I here at the midpoint of the AD, so have 0, 0. If you want to do, for example, K, the x-axis is half, the y-axis is 1 and no elevation, so half 1, 0. If you want to go to M, here M, no x-axis, you have y1, z is half, N, here the N, here if you do the perpendicular down, this is C, so the x-axis 1, the y-axis 1, and elevation is half. And if you go to P, if you do the perpendicular down, you have the x-axis 1, no y-axis 0, and elevation is half. If you want to go to S, for example, here, if you do the perpendicular, this is K, so the x-axis is half, the y-axis is 1, and the elevation is 1, etc. You can check it. T, if you do the perpendicular, the x-axis is 1, the y-axis is half, and the elevation is 1. The length of a vector V, if you have vector V which is PQ, it's x, if you do the norm, it's x of q minus x of p square plus y of q minus y of p square plus z of q minus z of p square, like we used to do in two-dimensional. And if you have the components of vector V, for example, v1, v2, v3, it will be v1 square plus v2 square plus v3 square. And if you want to add two vectors, you add the components, u1 plus v1, u2 plus v2, u3 plus v3. And if you want to multiply a vector by any number k, you multiply each entry inside by k. A unit vector, what is a unit vector? A unit vector is a vector. What is a unit vector of a vector V? It's a vector, same direction and parallel to V, but whose norm is 1. So it's a vector W. When I say V over its norm, it means 1 over V, which is alpha times vector V. What does it mean? W equal alpha vector V. It means W and V are parallel and same direction if alpha is positive, because here absolute value is positive. And more, they are parallel same direction. And if you want to do the norm of W, it's 1 over norm of V times norm of V, which is 1. So the unit vector is a vector parallel to that vector and same sense to that vector, but whose distance, whose norm is 1. So every vector V can be written as a product of its length, which is norm V, times its direction. When we say direction, it means times unit vector. So here V and V cancel out, so vector V equal vector V. So we say the product of its norm and its direction. So if I want to say write a vector whose norm is 5 and same direction as this vector V, so here I say vector W is 5, same direction, it means it must be parallel to vector V, and same the norm is 5, so here it must be 1, so I multiply it by its unit vector. Why? The unit vector of V over its norm, this is 1, and W equal alpha V, it means it's parallel to V. So here we find the norm of V, which is root 14, 1 plus 4 plus 9, so vector W will be 5 into minus 1 over root 14, 2 over root 14, etc. You have this vector W. Okay. Now we're going to start by the application problem. This is the given. Write the scalar components of vector AB. AB, so it's xb minus xa, so 7. 2 minus 3 is minus 1, so minus 3. I want to write it in scalar components, so this is the scalar component. So it will be 7i minus j minus 3k. And that I want it for u minus 2cb, so u is minus 5 to 3, minus 2 cb, so it's b minus c, so 5 minus 1, 4, and then you have 3 minus 4. I want the component, so you have minus 5 to 3 as it is. Here you multiply minus 2 by each one and you put plus. Minus 8, minus 6, plus 8, you add. So minus 13, minus 4, and 11. So in scalar components, it will be minus 13i minus 4j plus 11k. Now I want the vector norm of 2bc minus 3u. The components of bc here, 1 minus 5 minus 4 minus 3, 4. I want bc minus 2bc minus 3u. Sorry, here I did it as bc minus 3u, so let us correct it. So I want bc minus 3u. So this is bc minus 3u. So bc minus 3 times vector u. Vector u here is minus 5 to 3, so it's minus 4 minus 3, 4. Here it will be plus 15 plus minus 6 plus minus 9. You add the components, you have this one. I want the norm of that one. So it will be 121 plus 81 plus 25. Now I want to find point F having this relation. 2AB, this is AB, 2AB minus 3. F, I don't have it, so let us say it's XYZ. So it's XF minus X of A plus 2, Y minus 3 here, and Z minus 1 equal 3 vector U. This is vector U minus 5 to 3. So 14, here I have 14 minus 2 minus 6 plus minus 3x minus 6 minus 3y plus 9 minus 3z plus 3 equal minus 15, 6 and 9. I have 3 equations. 14 minus 3x minus 6 is minus 15. You're going to get x. Here minus 2 minus 3y plus 9 equal to 6. You get y. And minus 6 minus 3z plus 3 equal to 9. You get f. Here find vector r. So let r be x, y, z. So 2 vector r minus 3ab, these are the components of ab, equal 3 vector u. So I write 2r2 into xyz minus 3, these are the components, and this is the components of vector u. So 2x minus 21 equal minus 15. You're going to get x. 2y plus 3 here, plus 3 equal to 6, you get y. 2z plus 9 equal to 9, here you get z. Find ABC so that 2u minus 3cd equal vector v. CD, as you can see in D, you have A and C, B and C here. So 2 vector u, this is vector u minus 3, D minus C. Yani 3A minus 1, 5C plus 1, 2B minus 3 minus 2 is 2B minus 5 equal vector v. Same story, minus 10, minus 9A plus 3, as you can see here, equal to 2. You can find A. Here 4 minus 15C minus 3 equal minus 1. You're going to find C. And 6 minus 6B plus 15 equal to 1. You're going to find B. Now unit vector of vector u. So this is vector u. You need to find its norm. Root 25 plus 4 plus 9 root 38. So you divide the components of this vector u by root 38. You want that of AB minus 2V, the unit vector. You do AB minus 2V. AB, this is AB minus 2 vector V. So it will be 7 minus 4, which is 3. Here minus 1 plus 2 equal to 1. Here minus 3 minus 2 equal minus 5. So the components is 3, 1 minus 5. You do the square root. And then you divide this one, 3, 1 minus 5 that you have by square root 35. Find unit, write vector u as a product of its length and direction. So it will be u, vector u, it's equal norm u times its unit vector. So root 38 into the unit vector. And here the same story. You multiply root 35 by this one. Here find the vector r whose length is 10 and same direction as vector u. So you multiply 10 by the norm. Find terminal of a vector starting by a and equal to v, and am equal to v, you need to find m. So x plus 2, y minus 3 equal z minus 1, you're going to get it. And the last one here, you can do it by yourself.